In the previous video, we learned how to solve linear equations. In this section, we learn how to solve other types of equations. For example, we will learn how to solve rational equations and equations that involve radicals, square root, cube root, and things like that. So let's do some examples to understand how to solve these types of equations. For example, if we want to solve the equation 3x minus 1 over 3 minus 2x over x minus 1 equals x. This is a rational equation because it involves some rational expressions. Now, how to solve this type of problems? The basic thing here is to get a common denominator. We have the left-hand side. From the left-hand side, we can notice that in order to simplify the problem, we need to get a common denominator. So we multiply 3 by x minus 1 and the numerator 3x minus 1 by the other denominator x minus 1, and we multiply the other fraction by 3. Now the new denominator is 3 times x minus 1. The numerator is x minus 1 times 3x minus 1 minus 2x times 3 is 6x, all equal x. And now we simplify the numerator. We distribute x, so we get 3x squared minus x. We distribute negative 1. We get negative 3x plus 1 minus 6x all over 3 times x minus 1 equals x. Now we have 3x squared minus x minus 3x minus 4x minus 6x is negative 10x plus 1 over 3 times x minus 1 equals x. Now, after getting common denominator, we use cross multiplication. We cross multiply the expressions because we have a fraction on the left-hand side, a some fraction on the right-hand side, or some expression, so we can use this technique. So we multiply this numerator by the denominator of the right-hand side. So we have 3x squared minus 10x plus 1 equals x, the numerator of the denominator of the left-hand side by the numerator of the right-hand side. So we get 3x times x minus 1. Now we simplify the right-hand side of this equation. We get 3x squared minus 10x plus 1 equals 3x squared minus 3x. We distributed 3x on x minus 1 or over x minus 1. Now we can simplify this expression by subtracting 3x squared from both sides of the equation, and we get negative 10x plus 1 equals negative 3x. Now we have x on the left-hand side, x on the right-hand side, so we need to group them. So what is the smaller one? The smaller one is negative 10x, so we add 10x to both sides. This gives us 1 equals 7x because negative 3x plus 10x is 7x. And then we divide both sides by the coefficient of x. We get x equals 1/7. That's the solution. Now let's do another problem. If we have 3x plus 2 over x minus 2 plus 1 over x equals negative 2 over x squared minus 2x. This is another rational equation, and in order to simplify it, we need to get a common denominator of the left-hand side. So we multiply this by x minus 2 and this by x. So this gives 3x squared plus 2x plus, now 1 times x minus 2 is x minus 2. The denominator is x times x minus 2. On the right-hand side, we have negative 2 over x squared minus 2x. But x squared minus 2x is x times x minus 2 if we factor this out. And as we can see, if the denominators are the same on the left-hand side, right-hand side, we can cancel them. We can cancel this denominator and this denominator, and that gives us 3x squared plus 2x plus x this is 3x minus 2 equals negative 2. And then we add 2 to both sides. This gives us 3x squared plus 3x equals 0. Now, since x existed is in both of the two terms, so we can take 3x as a common factor and we get x plus 1 equals 0. And then we use the one of the properties that we learned last time. This property is the zero factor property. So either this equals 0 or this equals 0. And then we divide by 3, we get x equals 0. Here we subtract 1 from both sides, we get x equals -1. So the solution set is 0 and -1. But we need to check, are these the actual solutions for the equation? We notice that if we plug these into the original equation, they should satisfy the equation. If we can substitute -1, we don't have any problem with -1, but we have a problem with 0, because 0 makes this part, the second fraction or rational expression, equals 1 over 0, which is undefined. So we need to exclude this. So the solution set is not 0, -1, it's only -1. This is the solution set, because 0 does not belong to the domain. The domain here is everything except the 0 of this denominator, x equals 2, and the 0 of this denominator, which is 0. So if we get a solution that does not satisfy the equation, or that makes some troubles, I mean that makes the denominator equal 0, then we need to exclude that solution. So the only solution is -1. Now those were rational equations. What about radical equations, or equations that involve some square root or something like that? For example, if we want to solve x minus square root 8 minus 7x equals 0. In this type of problems, we need to isolate the square root. So we add square root 8 minus 7x to both sides. And then we get x equals square root 8 minus 7x. And then we need to get rid of the square root, because that prevents us from simplifying x here, or dealing with this x inside the square root. So squaring both sides of the equation, this gives x squared. Now, how to square the right hand side? If we square the right hand side, we cancel the square root with the square, and that gives us 8 minus 7x. And then we bring this expression to the left hand side, because we have x squared in the left hand side. And that can be done by adding the -8 plus 7x to both sides. This is 0, and then we get x squared plus 7x minus 8 equals 0. Bringing some part or some expression from one side to the other side of the equation, that means we change the sign of that expression. So now we have a quadratic equation. We can solve it by factoring this expression into x plus 8 minus 1. We need to find two numbers where the sum is 7 and product is -8. The two numbers are 8 and -1. Now, using the zero factor property, we have either x minus 1 equals 0 or x plus 8 equals 0. That gives us x equals 1 and x equals -8. So we have the solution set that consists of 1 and -8. Let's do another problem. If we have the fourth root of x minus 18 equals 3, here same thing, we need to get rid of the fourth root. So to do so, we raise both sides to the power 4, and that cancels the fourth root. We get x minus 18 equals 3 to the power 4. That means we multiply 3 by itself 4 times, and that gives us 81. And then we got a linear equation and it's very easy to solve this. We get 99. That's the solution. Another equation. If we have x to the power 3 halves equals 64, how to solve this problem? We can solve it using different ways, by different ways, but if we can think about, okay, so we are trying to solve for x, so we need to isolate x, but we have a problem here with the power. The power is 3 halves. How to get rid of this? To get rid of this, we either raise both sides to the power, the reciprocal of the power, I mean to the power 2/3, and then simplify, or we can first take the square root, because we can rewrite this using the radical, or it can be written as x to the power 3. This is the inner power, and this is the outer power, which is the index of the root. So the inner power is 3, the outer power is 2, but we don't need to write 2 here because the square root means the index is 2, equals 64. I rewrote the equation. I didn't do anything except converting x to power 3 halves to square root of x cubed. Now we need to get rid of the square root, so we can square both sides. So we get x cubed equals 64 to the power 2. And then we need to get rid of this 3. So to get rid of this 3, we need to take the cube root of both sides. And that cancels these. So we get x equals cube root of 64 squared. Now we need to simplify this. We can write this as cube root of 64 times 64. And then we can distribute the cube root. What is the cube root of 64? What is the number whose multiplication by itself 3 times gives 64? It's 4. So 4 times 4 is 16. So the solution is x equals 16. And as I mentioned, there are different ways to solve this equation. Now let's do another problem. If we have the equation 12x to the 4th minus 11x squared plus 2 equals 0. Now here it's not easy to deal with x to the power 4. We used to deal with x squared, but x to the power 4 seems not easy to deal with. So what should we do in this case? We can do the following trick. We can rewrite this as 12x squared squared. So x squared squared, that's x to the power 4 minus 11x squared plus 2 equals 0. I just rewrote it in this way for a purpose. Now we let x squared, this equals u. The equation becomes 12u, this is u, and we have square here, minus 11, this is u, plus 2 equals 0. Now we got a quadratic equation, and we know how to solve this type of equations. As we learned from the previous video, we have different, we can use any method that we are familiar with. And the method that we used last time is the following. We have 12u squared, so we write 12u over 12. And then we find two numbers where the sum is negative 11. The product is a times c. A is 12, c is 2, which is 24. So what are the two numbers? The two numbers are negative 8 and negative 3. The product is 24, the sum is negative 11. And then we simplify because we want to get rid of the denominator. So we can take 4 as a common factor of this. We get, of the first expression, we get 4 times 3u minus 2. And we can take 3 as a common factor of the second expression. We get 4u minus 1. So this becomes 3 times 3u minus 2 times 3 times 4u minus 1 all over 12. But we know that this is 4. We know that 4 times 3 is 12. So we can cancel this 12 with the 12 in the denominator, and this gives us 3u minus 2 times 4u minus 1, and this is equal to 0. Now we can use the property that we usually use in this situation, the zero factor property, and then we solve for u. We get 3u equals 2, and then we divide by the coefficient of u. U is 2/3, and for the second equation we add 1 to both sides, so we get 4u equals 1, and then we divide by the coefficient of u, so we get u equals 1/4. Is this the final answer? No, because the original equation is written in terms of x, and here the solutions are written in terms of u. So we need to go back to the substitution. X squared is u, so we need to replace x squared with u, or u. Since u is x squared, so we write this as x squared equals 2/3, and this is x squared equals 1/4. So we need to simplify more. We need to get rid of the square here, so we remember from the square root property that we discussed in the previous video that we can write x without the square root and put plus or minus on the expression on the right hand side, plus or minus square root of 2/3, and here same thing, x equals plus or minus square root 1/4, that's plus or minus 1/2. So the solution set is plus or minus square root 2/3 and plus or minus 1/2. Actually, you can simplify this expression because some people prefer to rationalize the denominator by multiplying by square root 3 here, and this gives us square root 2 times square root 3 is square root 6. Square root 3 times itself, that gives us 3. Now this rationalizes the denominator. Now the second part of the lecture is inequalities. That's 1.7, inequalities. What do we mean by inequality? Inequality is a mathematical expression that includes one of the following signs: greater than, less than, greater than or equal, or less than or equal. Now, what is the difference between inequality and equation? Let's take a simple example. If we have x greater than 2, this is inequality. If we replace greater than by equal sign, we get x equals 2. This is equation. Now, if we want to solve this, x is greater than 2. So on the number line, we have 2 here. It's open. That means 2 is not included because we don't have equality here in this symbol. If we don't have equality, we just put a circle on the number line. X are all the values that are greater than 2. That means all values here. So it's from 2, open at 2, because we don't have equality. 2 is not included in the solution set, to infinity. So that's the solution set. And that means we don't have just one value that satisfies this inequality. We have infinitely many values. If you substitute 3 here, 3 is greater than 2. If we substitute 4, 4 is greater than 2, and so on. Now, what about the equation? The equation x equals 2 is just a point on the number line. It's closed at 2 because we have equality. So it's just a point. That's one value. But for inequality, we get a strip of values, so we have infinitely many values. So that's the main difference between inequality and equation. Now, one of the important properties about inequalities is that if we need to multiply or divide by a negative number, then we need to reverse the inequality. If the inequality is greater than, then we reverse this to write it as less than. And if it's less than or equal, it becomes greater than or equal. If we need to multiply or divide by negative number. Now, solving inequalities is very similar to solving equations, but we need to add some more steps. So how to solve inequalities? For example, if we have 2x less than 4, we want to solve this inequality. To solve this inequality, we imagine that we have an equation. So we divide by 2, both sides by 2. And that gives us x is less than 2. On the number line, we have 2. It's open because we don't have equality here. X is less than 2. Any value less than 2, that means all values here. That means from negative infinity to 2. That's the solution set. Now let's take another example. If we want to solve negative 3x minus 1 greater than or equal to 5, we solve it as if it was an equation. So we add 1 to both sides, and we get negative 3x greater than or equal to 6. And then we divide by the coefficient of x, negative 3, negative 3. And since we divided by negative, we need to change the inequality, reverse the inequality. So we get x is less than or equal to negative 2. Now on the number line, we have negative 2. It's closed at negative 2 because we have equality here, as you can see. X is less than or equal to this. That means all values here. So the solution set is interval from negative infinity. Plus infinity and negative infinity are the inequality. The interval is always open at these values, negative infinity and infinity, because those are actually not numbers. These are just symbols. To negative 2, this is closed. One more example. Actually, all these examples that we discussed here are linear inequalities. So we started with linear inequalities. So let's do this problem. We have 4 minus 3x is less than or equal to 7 plus 2x. Here we have x written twice in this inequality. So as we do with equations, we need to first to add the inverse of the smaller value, or I mean to get rid of the smaller value, or to add the opposite of the smaller value to both sides. The smaller value is negative 3x. So we add 3x to both sides. So we have 4 less than or equal to 7 plus 2x plus 3x is 5x. And then we subtract 7. We want to isolate x. So we get negative 3 less than or equal to 5x. The last step is to divide by the coefficient of x. And that means this expression is less than or equal to x. That means x is greater than or equal to this expression or this number. So on the number line, it's closed because we have equality closed at negative 3 halves, and x is greater than or equal to this. That means all values here. So from negative 3/5 to infinity. That's the solution set. Now sometimes we have more than inequality symbols in one inequality or one expression. So for example, negative 2 is less than 5 plus 3x less than 20. We want to solve this. So in order to solve this, we need to isolate x. So we subtract 5 from each side, from each part of the inequality. So we get 3x is between negative 2 minus 5 is negative 7. On the right hand side, we have 20 minus 5 is 15. And then we divide by the coefficient of x. We get x between negative 7/3 and 15 over 3 is just 5. So on the number line we have negative 7/3. It's open because we don't have equality here. And to 5, and here we have 5. It's open because we don't have equality as well. So x is between them. That means here x is greater than this number and less than this number. So how can we write this using interval notation? It's open at negative 7/3 and open at 5, and any value between those two numbers should satisfy this equation or this inequality. For example, we may choose 0. 0 belongs to this interval, so if we substitute 0, we get negative 2 less than 5 plus 3 times 0, which is 5, less than 20. And that's correct. Negative 2 is less than 5 and 5 is less than 20. That's correct. And this is true for any value between those two numbers or values, negative 7/3 and 5. Now one application, simple application, is the revenue and cost. So if the cost function is given by 35x plus 500 and the revenue is given by 60x, we want to know now if we want to find x number of products that satisfy the break even. So we have break even if the revenue is at least equal the cost. That means greater than or equal to the costs. So we want the revenue R of x to be greater than or equal to the cost function. So R of x is 60x greater than or equal to the cost function. The cost function is, let me change this to 35. So it's greater than or equal to 35x plus 500. And then we solve this inequality. We have x on the left hand side, x on the right hand side. So the smaller one is 35. So we subtract 35 from both sides. We get 25x greater than or equal to 500. And then we divide both sides by 25 to get x greater than or equal to 20. On the number line we have 20 here. It's closed because we have equality. X is greater than or equal to this. That means to the right. So the solution set is, or the interval is 20 to infinity. So any value between 20 and infinity, or from 20 to infinity, will satisfy the break-even. Now, sometimes we deal with inequalities that involve quadratic expressions. So quadratic inequalities. So here the idea is that we need to convert this into equation by just replacing the inequality symbol with equality, and then we solve, and then we study the sign. We make a sign chart. So how to do this? For example, if we want to solve the inequality x squared minus x minus 12 less than 0. Now the first step is to convert this into an equation by replacing less than with equal sign, and then we solve this equation. So the factors are 3 and negative 4. 3 times negative 4 is negative 12. 3 minus 4 is negative 1. That's the sum. Now we have x plus 3 equals 0, or x minus 4 equals 0. That's the zero factor property. And then we subtract 3 here, we add 4 here, we get x equals negative 3 or x equals 4. That's the solution set. Now we need to check this sign. So we have two values, negative 3 and 4. Is it open or closed at these? Since we don't have equality here in the inequality, we leave it open. Now we study the sign. We choose some value greater than 4, like 5, and substitute it either here in the original one or here in this expression. And we just want to determine the sign. We don't need to worry about the how much or the value of the number or that number, that output, but we only need to worry or to pay attention to the sign of that number. If we substitute 5, let's substitute it here because this is equivalent to the left hand side here. If we substitute 5 plus 3, this is positive. 5 minus 4 is positive. Positive times positive is positive. And then we choose a value between negative 3 and 4. Let's choose 0. Now if we substitute 0 here, 0 plus 3 is positive. And here 0 minus 4 is negative. Positive times negative is negative. Here we choose a value less than negative 3. Let's choose negative 4. Substitute here. Negative 4 plus 3 is negative. Negative 4 minus 4 is negative. Negative times negative is positive. Now, the inequality involves less than an expression that's less than 0. That means negative. So we need to choose this interval. So the solution is negative 3 to 4. So we choose this interval because we have expression that's less than 0. Now let's do another example. If we have 2x squared plus 5x minus 12 greater than or equal to 0, we first convert this into an equation. We write it as an equation, and then we need to factor this. We have 2x over 2, and then we find two numbers where the sum is the middle term or the middle coefficient 5, and the product is a times c. 5 times negative 12, that's negative 60. Now the two numbers are 8 and so here I think I made a mistake here. So the product is negative 24, not negative 60. So the numbers are 8 and negative 3. Positive 8 and negative 3. Positive 8 times negative 3 is negative 24. Positive 8 plus negative 3 is positive 5. Now we simplify. From the first expression, we can take 2 as a common factor. And then we rewrite. And from the other, we can't simplify the other expression. We don't have common factor. So we have 2 times x plus 4 times the second expression, 2x minus 3 all over 2. We cancel the 2 from the numerator, from the denominator, and set this equal to 0. So we have x plus 4 times 2x minus 3 equal to 0. And using the 0 factor property, we have x plus 4 equals 0 or 2x minus 3 equals 0. We solve these equations, linear equations. We get x equals negative 4. When we solve this, we get 2x equals 3 and then divide by 2 to get x equals 3 halves. So we have two values. We put them on the number line, negative 4 and 3 halves. And since the inequality involves equality, greater than or equal, it will be closed at those 2 points. And then we study the sign. We can choose a value that is greater than 3 halves. Let's choose 2. If we choose 2 and substitute it, let's substitute it here. 2 times 2 squared, that's 8, plus 2 times 5, 10, minus 12, that's for sure greater than 0. It's positive. And between negative 4 and 3 halves, let's choose 0, substitute it here, we get 0 plus 0, minus 12, it's less than 0. Let's choose a value that's less than negative 4, let's choose negative 5, and substitute it here, we get 25, negative 5 squared, 25, times 2, 50, 5 times negative 5 is negative 25, minus 12, we still have positive value. Now, the inequality says the expression should be greater than or equal to 0. That means positive or equal to 0. So this expression here, or this part, and this part, the function is positive on these intervals. So the solution is negative infinity to negative 4, closed at negative 4, union from 3/2 to infinity. Union, that means we put, because we have two intervals or two solution sets, so in order to combine them we use the union symbol. Now sometimes we have rational inequalities. For example, if we have 5 over x plus 4 greater than or equal to 1, how to solve this inequality? Now in this case we need to make the right hand side equal to 0. Right hand side must be 0. How to do that? We need just to subtract 1 from both sides. We get 5 over x plus 4 minus 1 greater than or equal to 0. Now the right hand side is 0, and then we proceed as before. We can convert this into equation, so we write 5 over x plus 4 minus 1 equal to 0. We convert it into an equation. Then we get common denominator. By multiplying this by x plus 4. So this gives us 5 minus x plus 4 over x plus 4 equal to 0. And then we simplify the numerator. We get 5 minus, we insert the negative sign on this expression. So we get 5 minus x minus 4 over x plus 4 equal to 0. And we can simplify the numerator. We have 5 minus 4 is 1 minus x over x plus 4 equal to 0. Now this can be equal to 0 only if the numerator is equal to 0. 1 minus x equals 0. And then we find that x equals 1, because if you add x to both sides you get x equals 1. And then we find the 0 of the denominator as well. X plus 4 equal to 0. We get x equals negative 4. On the number line we put those two values. Negative 4 is always open. The 0 of the denominator is always open because that does not belong to the domain. That makes troubles if we substitute it. So we need to exclude it even if we have equality here in the original inequality or problem. And at 1, now the numerator depends on the symbol or the inequality symbol that we have. We have greater than or equal. That means at 1 it will be closed. Now we study the sign. We can choose some value here. Greater than 1, let's choose 2. If we choose 2, we can substitute here. Let's substitute 2. 5 over 2 plus 4 is 6 minus 1. Is this greater than or equal to 1? This is less than 1, so the answer is negative here. We choose a value between negative 4 and 1, so let's choose 0. If we choose 0 here, we get 5 over 4. Here 5 over 4 minus 1. 5 is greater than 4. That means this expression is greater than 1 because the numerator is greater than the denominator, and that means we get positive value. Now we choose a value less than negative 4. Let's choose negative 5. And we substitute here 5 over negative 5 plus 4, which is negative 1 minus 1. Negative minus negative is negative. Or we can substitute here, if that's simpler. Now the inequality determines which interval we have to use. The inequality includes greater than or equal. That means positive or non-negative, non-negative in this interval. So the solution set is negative 4. It's open at negative 4 to 1. It's closed at 1. Now the last part, just some note on some types of inequalities. If we have x plus 5 times 3x plus 6 times 2x minus 14 greater than or equal to 0, we want to solve this. We need, since these are factors, we first set this equal to 0. And then we set each one of these equal to 0 using the 0 factor property. X plus 5 equal to 0, 3x plus 6 equal to 0, and 2x minus 14 is equal to 0. Then we solve this to get negative 5. We solve this to get negative 2. And we solve this to get 7. And after that, we put them on the number line. We have negative 5. It's closed because we have equality here. And negative 2 and 7. And then we study the sign. We can choose a value greater than 7. We find that this expression is positive. Between negative 2 and 7, let's choose 0. Now this gives positive. This gives positive. This gives negative. Positive times negative is negative. We can choose a value between negative 5 and negative 2. For example, negative 3. If we substitute it here, we get positive. If we substitute it here, we get negative. If we substitute it here, we get negative. Negative times negative is positive, so this is positive. And if we choose a value here, we get negative. So the inequality is greater than or equal to 0. That means this interval and this interval. So the solution set is negative 5 to negative 2 union 7 to infinity.